Okay, we're going to be finishing up our chapter with hypothesis testing. So this is where we're actually going to be using some of the statistics to validate certain claims. So what is a hypothesis? Well, basically it is a claim that we want to test, where we're going to check to see if it holds true. Now, we aren't really proving that it's true, because when statistics, again, we aren't testing an entire population. So if we were able to test an entire population, then yeah, we could certainly head towards proving something. But what we are seeing is if the available evidence, if what we can figure out supports whatever the claim is. And our claims basically come in two types. The first is called the null hypothesis, or H naught. And we symbolize these with values as less than equal, equal, or greater than equal. And generally, this is going to be what is currently accepted. This is the value that we always will test. We always test H naught. The alternative hypothesis, symbolized with HA, that's an A right there, is symbolized with a less than, not equal, or greater than. And it's called the research hypothesis because it's going to determine how we are actually going to test our hypothesis. So what we're going to be looking for is we're going to have our distribution, whether it's t or normal. It's not going to really matter for this, but basically we're going to see if our hypothesis is within what's called the critical region. So we'll have our distribution, we'll say like maybe this is our critical region, and if our hypothesis actually ends up in here, well then we're going to reject it. So let's take a look. So again, we are always going to test our H naught, but we have to be able to write H naught. So let's take a look at a few claims and see if we can write these down. So again, we're going to have, when we test, we're going to have two basic outcomes: rejecting our hypothesis, reject H naught, or we're going to fail to reject H naught. Now I thought I had, let me check. Oh, yep, there we go. Okay, so we need a way to measure to decide whether we're going to reject or not reject. And that is called significant or statistical significance. And generally we're like going to be in the realm of like 5% or 3% significance, generally is the case. And that symbol is going to be alpha. And alpha is the statistical significance. And statistical significance is going to be basically the same as what we just did with confidence level. Really are telling us the same thing. So if I say I want a 97% confidence level, then that means I want a 3% statistical significance. Likewise, if I said I wanted a 99% confidence level, well then that means my alpha is going to be 0.01 from 1%. So it's like basically you take your confidence level and you subtract it from 100. All right, so I was saying before I got sidetracked here that we wanted to be able to write these statements, these hypotheses. So let's take a look at a few claims. So here's our first claim. Juicy Fruit says that their gum lasts at least 3 hours. So we want to keep in mind that H naught we're going to write with greater than equal to, less than equal to, or equal to. And we're going to write H alpha with greater than, less than, or not equal. And the reason is because this is what we're using to actually set up our how to test our hypothesis. All right, so how do we write this? Well, H naught in this case is going to be, they say their gum lasts at least 3 hours. So I would say that mu is greater than or equal to 5, which means our alternative hypothesis, the how we're going to test this, would be mu is less than 5. And notice that these are opposites. All right, let's try another one. Jiffy Lube does oil changes in less than 15 minutes. So we might be tempted to say that our mu right here is less than 15 and just copy it down, but this is not greater than, equal to, less than, equal to, or equal to, so that's not going to be correct. We don't want that. So they do their oil changes in less than 15 minutes, which means our mu is greater than or equal to 15. And our test hypothesis, or our alternative hypothesis, could be mu is less than 15. So our alternative is always with the less than, greater than, or not equal to, because it's going to set up how we test these. Devin complains students have more than 30 minutes of homework. That's an HW right there. Devin doesn't realize most students don't even bother doing their homework, so what matter does it make how much they have? But anyway, so Devin complains students have more than 15 hours of homework. So the way he stated that is going to be an alternative hypothesis. Mu is greater than 30, which means our H naught is mu is less than or equal to 30 minutes. All right, and again, we can see that these are opposites. All right, McKeel runners finish a mile in 4 minutes. So H naught is going to be mu exactly equals 4 minutes. That's a pretty bold statement right there. That's actually would be really good. And our alternative would be, well, they don't actually do 4 minutes. And we could easily test that. All right, so we're going to want to get move towards actually trying a few of these things. But as we move into that, let's see what kind of tests we have. Now, our tests are determined by our alternative. We will test H naught, but we're going like against this. This is going to set up the, like you could think of it as setting up the criteria for testing together with our significance level. All right, so we have 3 tests. So we have and we'll want to draw, at least I would want to draw, our possibilities here. And these are supposed to be normal distributions, but I'm not having good handwriting. A left-handed test is going to be like when H alternative is less than, when we have a mu less than case. So like we have an area right here. And our central, meaning that we have like 2 ends, in which case we have to take our significance level, our alpha, and divide it by 2. Over here, our alpha is just, there's our alpha. But I'd have alpha divided by 2 on both sides because I'm going to be testing right here and right here because I'm saying like it's centered around. And this is when our alternative is like not equal to something. So we're looking, is it way out here or not? Our right-handed is going to be like our alpha is way over here. And this is going to be our critical region. So if our H naught is in the critical zone, so if I find that H naught is inside of here, or inside of these, or inside of this, well then I'm going to have to reject it. Now, though we could test this directly, I think it's probably better that we just move directly to doing what's called the p-value. And it's similar in a way to t-values and in z-values. But basically what we're going to do is we're going to find the p-value and we're going to decide based upon this. And the p-value is going to be compared to our alpha. And if we see that the p-value is, that is the wrong symbol. If we see that the p-value is greater than alpha, we're going to say that we do not reject H naught. And if our p-value is less than or equal to our significance level, we reject H naught, whatever it happens to be. So let's go ahead and take a look at a problem. So I think that's really the best way to do these. But we want to keep in mind, and I'll leave this up, are things to remember. So we need to know when we're going to use z-scores. And z-scores are going to be used when we have a sample size greater than 30. Now, there are other criteria, but for most of these questions, it's going to come down to sample size. So if our sample size is greater than 30, we're going to use a z-score. And we'll use a t-score if our sample size is less than 30. And we'll want to keep in mind our formula to get our z or t-score, which is our sample mean, subtract our mean, divided by our sample deviation. That's what that symbol there is with the mu, our sample standard deviations. And we get that by this formula, standard deviation divided by the square root of n. And we got that when we talked about our confidence levels. All right, so let's keep that up. Let's take a look at our first example. So we have Grandma's Cookie Factory has on their packages this phrase, no more than 5 grams of fat on the packaging. And our pre-calc class is going to sample cookies because why not? So we're going to sample 50 cookies. So right away we know we're using a z-score because we have a sample size greater than 30. And we find, okay, the pre-calc class finds that the mean is 5.03 grams with a standard deviation of 14 grams. So we want to determine, is the package claim valid within 95 confidence? So let's dissect that. That means our alpha, our significance level, is going to be 5% or 0.05. Now let's write our H naught. We want our H naught statement. So our H naught statement, what is this going to be? Well, take a look at this. No more than 5 grams of fat. So we could have 5 or more. So mu is less than, I read that backwards. We want less than or equal to 5. And our alternative hypothesis, well, mu is greater than 5. So it's kind of looking bad for the cookies right here. So let's just draw a quick picture of this. Here we go. And remember, we use this to set up our test. So our test is going to be over here. So the question is, how are we going to get this p-value? Well, first of all, let's go ahead and calculate our z-score, because we can do that right away. So our z-score, which is going to measure how many standard deviations we are from the mean, we're going to use this formula right here. So we have our 5.03. We're going to subtract our accepted value of 5 grams. And then we need to find our deviations of the sample means. So that's this the symbol right here. So let's find that. So we take our mean of our samples our deviation, is 0.14, and we're going to divide that by the square root of our sample size, so square root of 50, and I had all these written down somewhere. Oh, there. And we get 0.02. So we'll substitute that in right here, and we get our z-score by typing this into our calculator of 1.5. Now, since we're using z-scores, we're going to go ahead and go to our calculator. And in our stats menu, we're going to find our norm CD. And we're going to put in our z-score. Now, we're doing a right-handed test here. So when we do our norm CD, we're going to put in our standard deviation right here. We are doing a right-hand test, so we'll actually put, instead of putting our 4 or our 10 or whatever, how many deviations we're going to use, I'll use 10. We'll put that in on the right-hand side, and we get out 0.066, hopefully I'm reading that right, 8. So if our P, now this is our P, so our P is this, that's P. Our confidence level that we want is 0.05. So let's take a look. Our two options was if P is less than or equal to alpha, then we reject. Does not look like we're going to reject. If P is greater than alpha, that seems to be the case because we have 0.0668, and that's greater than 0.05. So it looks like the cookies are doing pretty good. So, I didn't have the answer there, and I wanted to make sure that we did it right. Let's see. Well, I guess I don't have that answer handy. Oh, nope, there it is. Actually, it's in your textbooks. It's page 707. And yeah, that is not enough information to reject. So we do not reject. So good job, Cookie Company. Wasn't looking good there with that 0.05, but or 5.03. But we do not reject the claim. So the claim holds. Now, we haven't proven the claim. We just don't have enough information. The evidence does not support that, at least not at the confidence level that we wanted in the problem. Let's try another one. Okay, Matthews Trucking Company guarantees delivery in less than 5 days. A sample of 40. Okay, so again, we're going to be able to use z-score. So we're using z-score. Has an average of 5, so average another way to say mean, of 4.9 and a standard deviation of 0.2. So let's go ahead and take a look at if we can reject this claim with a significance of 5%. So this time we're told directly our significance level. So let's think about what test we're doing here. Let's think about that first. So get our H naught. They say they do it in less than 5 days. So mu is less than 5, which means our test, just made a mistake. That's actually our alternative hypothesis is less than 5 days. This has to be greater than or equal to. So our H naught is it greater than or equal to 5 days? Always the less thans are the alternative. So I'm testing the left-hand side. I'm doing a left-hand test here, and I'm asking, are we down here? So our 5% confidence level. So I'm looking, my alpha is 0.05. That's the confidence or significance level that I want. So let's go ahead and calculate our z-score yet again. So we need, in order to do the z-score, we need our sample mean, our deviation of the sample means. So we'll get that first. Our standard deviation was 0.2, getting it from right there. And our sample size was 40. And we'll go ahead and put that in the calculator. And it looks like we get 0.0316228. I don't need all those places. So now when I calculate my z-score, I'm going to use 4.9 minus the 5 divided by this number, 0.0316. I'll keep the 2. And I get out z is negative 3.16. So I'm way down here somewhere. Okay, I need my p-score. So since I'm doing z, I can do norm, CD. Now I'm testing the bottom, right? So I'm going to do negative 10, comma, negative 3.16. I'm going to see what that actually pops out for us. and something very, very small. So just to talk about that, this is what my calculator pops out. And then I have E negative 4. So what that means is I move this decimal point 4 spots. So if I add some zeros here, 7, 1, 2, 3, 4. All right, so that's really small. And right here, I have a significance level of alpha. Now let's recall again, just to hit this one home, is if P is less than or equal to alpha, I am going to reject. And if P is greater than alpha, I do not reject my H0. So let's take a look. This is my P. So P is this, and alpha is this. And it's looking like P is less than my alpha. So I have a P is less than alpha case. So I can reject this claim. So what does this mean? I reject H0. This is rejected. This is not the case. So what does that mean? Well, apparently this is going to hold, that they are able to deliver in less than 5 days. So remember, we got to keep track of what we're actually rejecting. All right, we're getting towards the end here. I know I've been talking a lot. Hopefully the bell hasn't already run. All right, CVS manufactures 50 grams of tablets. The quality control team wants to test those. They test 20. All right, so we're doing a T-score now. Doesn't change much about what we're going to do. And it finds a mean of 49.7 milligrams with a standard deviation of 0.6. Test the claim with a significance of 5%. So our alpha is 0.05. And I want a quality control test, okay, of 20. So I'm doing a T-score. So my T. Well, what's my H0? Well, this is going to be tricky, but our H0 is mu equals exactly 50 grams, which means our alternative, what we're testing, how we're setting up our criteria here is that, well, is it not 50? So when I take a look at my norm, when I'm saying, here's my middle, I'm actually testing both sides. This is the central case. I'm testing both of those sides. So I actually have to divide this into 0.025 and 0.025 on either side of my curve. All right, let's get our sample deviations. So we need our deviation of 0.6 divided by our sample size, square root 20. And when we do that, I get 0.1677. I'm going to use that with my T-score. So my T-score is basically the same formula right here. So I have the 49.7. I'm going to subtract from it the 50 and divide by my sample deviations, so 0.1677. That gives me a T-score of, what is it? I did it earlier. Negative 2.68336. All right, so now I can't use the normal. I have to use the T distribution. So it's going to be still in our stats menu. And we're going to type in, on my calculator, comes in TCD. Now we have some more inputs we need to do. So what do we want to test? We want to test this left-hand side or this right-hand side. This would be the negative case, right? So I have a T-score negative right here. So I'll test that side. So actually, I forget which order I put this in. So I think I'm going to put in the negative 10. And then I think I'm going to actually test it first. I didn't do this one this way earlier. And then 19, let's see. So that's should hold on a second. Gotta check this one. Yeah, we should have rejected that. Yep. Okay, good. I was just making sure that answer was right. Okay, so, all right, the order I put this in anyway, I did -10 for my number of deviations, and I put in my t-score. I'll just write the t right here. And then remember that when we're doing the t-distribution, we need the number of degrees of freedom. And in this case, that's actually going to be 19. Well, why is it 19? Because I have 20 in my sample size, which means 19 of these numbers could actually be anything they want, and the 20th has to be a certain thing. So we have 19 right there for our degrees of freedom. And when I do that, I actually get, this is exactly what the calculator pops up. E to the -3. So that means move this decimal point 3 spots. 1, 2, 3. And this is my p-score. All right, so my p-score is less than my confidence level. Yes, it is. P is less than my alpha. So what does that mean if P is less than alpha? That means I am going to reject H0. So what was H0? That it's 50. So this is rejected. That does not happen. So what does that mean ultimately for us? We are going to say that the claim that the tablets are 50 milligrams is not true. So this one's looking pretty good, that they are not 50. All right. Time for one more? Hopefully there's time for one more. All right, Zen Sleep, our sleeping tablets. So they say that their product provides more than 8 hours of sleep. More than. Well, that sounds like more than, that sounds like mu is greater than 8. That means H0 less than or equal to 8. So we have 50 users we're going to test to make sure. And they have a mean sleep of 8.07 with a standard deviation of 0.3. Is the claim supported with 97% confidence? That's going to be an alpha. We're going with a statistical significance of 3%. That's 0.03. And what we're going to do is we're going to go ahead and get our, can we do a z-score? Yeah, because we have 50 in our sample size. So we are going to do a z-score. Let's get our sample deviations. That's 0.03 divided by our root of 50. And that gives us 0.0424. And then we'll bring it up here. 8.07 minus our 8 divided by our previously calculated number there. All right, and what do we get? 1.651. That's our z-score. So we're going to use our norm CD. I think I got a little bit ahead of myself. Did we even talk about this? All right, so we need, what are we testing right here? So we're testing over here, right? A right-handed one. How do I know? Because I'm looking at this. This tells me. My alternative hypothesis tells me my critical zone. And we're remembering and keeping in mind, of course, that if our P score is less than or equal to our significance, then we're going to reject. All right, so let's norm CD this. And I want this right-hand side, right? I want the right-hand side, so I'm going to put in my 1.651 first, and then a 10 for 10 deviations from the mean, because I want that area under the curve. And I get out, this one's a little bit more reasonable. That's what I get for my p-score. And my alpha is 0.03, and I see that I have a case where p is greater than alpha, which means H naught is not rejected. So it looks like, even though that kind of seems reasonable right here because they're sleeping more, and with a deviation of 0.03, I mean, that's a pretty big deviation considering we're talking about hours, is still within our confidence level. So we can say that this holds true. I haven't proved it, but it holds. It's the opposite. So that means that these guys are liars. Yep, these guys are liars. So that's not the case. This is the case because it flipped around. Yeah, always write your H naught and your alternative down so you know what you're talking about. So this right here, it says they provide more than 8 hours of sleep, but that was our alternative hypothesis. Our H naught, our null hypothesis was actually our sleep is less than or equal to 8. So that ended up getting not rejected. Not rejected. So we are good. All right, that's all the examples.